Yes.
Okay, that's great. Okay, what screen do you see right now?
Chapter 3.
What do you see?
The PowerPoint Chapter 3.
Oh, chapter 3. Yeah, that's correct. Okay. Okay, shall we start chapter 3? Shall we start? Hello, I'm asking you a question, guys.
Yeah.
Yes.
Okay. Guys, are you familiar with the time value of money? Guys, please answer my question. There is a reason I asked you a question. Are you familiar with the time value of the money?
I can view.
Hmm?
Yes.
Okay, by the way, we go through the concept. It's okay. This is part 1. Okay, learning objective is calculate future values and understand compounding, calculate present values and understand discounting, calculate implied interest rate and waiting time from the time value of money equation, apply the time value of money equation using formula, calculator, and a spreadsheet, explain the rule of 72, a simple estimation of doubling values. Okay. Future value and compounding interest. Guys, as you know, finance talks about future always, yeah? It's all about finance. That mostly talks about future. What does that mean? What do you understand from that? It means that if you want to accept or reject any project, if you want to do an investment, it's about future, yeah? But we need to make decision right now. It means that in finance, we do the time travel. From the present time, we go to the future time. From the future time, we come to the present time. And we take the present value, any amount of money, present value, we take it to the future value, and we bring the future value in terms of monetary value, we bring it to the present time, okay? And if we take a value from present time to the future time, this action is called compounding. If we bring the future value to the present value, this action is called discounting. Future value and compounding interest. The value of money at the end of the stated period is called the future or compounded value of the sum of money. Determine the attractiveness of alternative investments. Figure out in the effects of inflation on the future cost of assets, such as a car or house. Okay, what does that mean? What are we talking all these things? Okay. I'm gonna draw something here. So, see, this is called, I'm sorry for my drawing. Forgive me for my drawing, yeah, because it's my first time trying to draw something. My drawing is not really great. Okay. See, if we call it 0, means it here is called present time. Or if you have any value, it's called present value. It means that if I have, for example, 100 ringgit in my pocket, okay, right now. And I want to know that how much it's gonna grow after a year. It's supposed to be a year. 1 means year 1, okay? It means that I want to take a value from right the present time, take it to the future time. And I want to know that if I invest 100 ringgit right now, how much this money gonna grow after a year? Means that how much I will be having in 1 year time, or how much is its future value, okay? Are we okay up to here?
Yeah.
Yes.
Okay. What if I know that in 1 year time, I want to buy a house or a car, anything that costs me, for example, 100K in 1 year time, in future time, future value, future time. Then I want to know that how much actually I supposed to invest right now at present value, at present time. I want to know that how much I supposed to invest right now. Okay? Are we okay with that? Then bringing the
Yes.
future value to the present value, present time is called discounting. In here, if I want to take a present value and invest it and have some value, and in the future, this action is called compounding. Okay? There is a relationship between the future value and the present value. This relationship is shown by this formula. Yeah, as you can see, this formula helps us to relate the future value to the present value, which we just write it like this: future value equal to present value multiplied by 1 plus R or I, it depends. R or I is called interest rate, to the power of N or T. Okay? Are we okay?
Yeah.
Okay, future value equal to present value multiplied by 1 plus I, or is the same thing, to the power of T or N. These two are the same. See, there is an example here. It says that, let's say John deposits $200 for a year in an account that pays 6% per year. At the end of a year, he will have how much? That's the question, yeah? See, okay, if you refer it to this formula here, we can plug in everything in this formula. Okay, the formula is like this, isn't it? Future value equal to present value 1 plus I to the power of N. Okay, he's looking for the future value. How much he investing right now? 200 ringgit. The question is giving us 1 plus how much is the interest rate? 0.06%. And for how long he is investing his money? 1 year.
1 year.
1 year. Then if you put all this in the calculator, then we're gonna get this number, 220 is here. 212 actually. Yeah, see? 212. Okay, are we okay? This is the simplest form of the relationship between future value and present value, which is called the single period scenario. See here? It is called the single period scenario. What does that mean? What does that mean? It means that if we have just a single cash flow right now, for example, I have 100 ringgit in my pocket, and then I want to grow this money to the future. See, this is a single cash flow that I have. Or if I want to have this amount in the future, I need to know that how much do I need to invest at the present time. Okay? See, we are just dealing with the single cash flow. That's why in here it is called the single period scenario. Any question up to here?
No.
Okay. Then let's move on. The multiple period scenario. We have seen this formula right now, yeah? You need to remember or maybe memorize this formula, but that's the most important formula in the finance for you. The multiple period scenario means future value is always equal to present value multiplied by 1 plus R or I to the power of N or T. Yeah, if you can remember this formula would be really great. Okay, there is an example. If John closes out his account after 3 years, how much money will he have accumulated? How much of that is the interest on interest component? What about after 10 years? Okay. Okay, he gonna deposit 200 ringgit right now, isn't it? Based on this question, I'm not sure what is here. Let me close it down. Okay. Okay. Question is says that right now he has how much in his account? 200 ringgit. He wants to know that how much he gonna have after 3 years. Okay.
3 years.
Then after 3 years, we want to know that how much he gonna have. Okay, this is how we're gonna perform it. See, we refer to this formula here, means we are looking for the value in 3 years time, isn't it? Future value in year 3. Okay, the present value, the amount that we are putting, the investing right now is, how much is it? 200 ringgit. Okay, this money gonna grow with the interest rate of 6% for how long? For 3 years.
3.
Yes. Then you're gonna see that this would be 238.20. Yeah. Okay. Question is asking that how much of that is the interest on interest component. Okay. Means that, see here, interest on interest is here. Okay, first we're gonna calculate that in 3 years time, how much interest he is earning actually. He invested 200 ringgit, $200. Interest rate was 6%, and for 3 years time, isn't it? When we multiply these three numbers together, it means that in 3 years time, he earned $36 as an interest. Okay, but the money that he has after the, year 3 is 238.20. Okay, 238.20 minus 200 that he originally invested, minus the amount of interest he got, the remaining is 2.20. This 2.20 is called interest on interest actually. That is a compounding factor. Okay, it is called interest on interest or the compounding factor. Okay, one question. Why do we use interest rate at all? What's the usage of interest rate? Okay, interest rate in a way is the cost of the money, or interest rate gonna compensate the investor for the inflation rate. What does that mean? It means that if you have 100 ringgit right now in your pocket, does it have the same purchasing power in 2 years time? No, the purchasing power gonna drop. What does that mean? It means that maybe, for example, you can buy a good meal. For example, if you go, give me an example. Okay, maybe you can buy a sunglasses with 100 ringgit right now. Do you think that in 3 years time, can you buy the same sunglasses with 100 ringgit? No.
Oh.
No, because of the inflation, the value of the money, the purchasing power of your money gonna drop. Maybe in 3 years time, you need to pay 120 in order to buy the same sunglasses, okay? When the value of the money drops, when your purchasing power drops, for you, if you want to have the same purchasing power right now and in 3 years time, you need to be compensated through the interest rate. That's why we use the interest rate in our calculation. Okay. Referring to the previous question, we can solve that question in many different ways. See, there are 4 different ways is offering, we can do that question. See here, there are 4 different ways. Method 1, methods of solving future values. You can use the formula that we already did. You can use a financial calculator, okay? Later, you can, if you want, you can buy the financial calculator and you can solve this type of a question with the financial calculator. You can use a spreadsheet method, means that you can use the Excel. And for this module, you need to learn Excel by yourself, okay? I try to give you some material, some videos from the YouTube, but you need to learn it by yourself. And the method 4 is referring to the time value table. There are many different ways of doing the same thing, okay? Okay. See, there is another question. Methods of solving future value problems. Example 3, compounding of interest. Let's say you want to know how much money you will have accumulated in your bank account after 4 years. If you deposit all $5,000 of your high school graduation gifts into an account that pays a fixed interest rate of 5% per year. You leave the money untouched for all 4 of your college years. See, all the information is given to you. You have the interest rate, 5%, and you want to invest it for 4 years, and the amount that you invest is 5,000. We just plug in everything in the formula. See here is 5,000, 1.0.5 to the power of 4 would be 6,000. And $77.53. And see, they are doing it with method 1, method 2, method 3, and method 4. Okay. Methods of solving future values. Future cost due to inflation. Let's say that you have seen your dream house, which is currently listed at $300,000. But unfortunately, you are not in a position to buy it right away and will have to wait at least another 5 years before you will be able to afford it. If house values are appreciating at the average annual rate of inflation of 5%, how much will a future house cost after 5 years? Okay, see the answer. The current cost of the house is $300,000, and you want to buy it after 5 years. The inflation rate or the interest rate in a way is 5%. And then after 5 years, the house gonna cost $382,884.5. Yeah, this is how we find the future value. And okay, in here also show how to solve the same question different ways. Use calculator, using the Excel, and use the time value table. Okay, what does here talk? It says that, okay, this was the formula, yeah? FV equal to PV 1 plus I to the power of n. So how many variables do we have here? We have 1 variable, 2 variable, 3 and 4 variable. If we have 3 of these variable, we can find the another variable. For example, if the future value is given to us, if the interest rate is given to us, if the n is given to us, then we can find the present value. How to find the present value? Present value would be present value equal to future value divided by 1 plus I to the power of n. Yeah? We are just readjusting the formula. See, present value and discounting involves discounting the interest that would have been earned over a given period at a given rate of interest. It's therefore the exact opposite or inverse of calculating the future value of a sum of money. Such calculations are useful for determining today's price or the value today of an asset or cash flow that will be received in the future. We have seen this formula right now here. Okay, let's see an example. For the single period scenario, means that we just have single cash flow. When calculating the present value or discounted value of a future lump sum to be received one period from today, we are basically deducting the deducing the interest that would have been earned on a sum of money from its future value at the given rate of interest. Okay. And we have seen this formula also. Nothing new for you. Okay, there is an example. Present value and discounting. Let's say you just won a jackpot of $50,000 at the casino and would like to save a portion of it so as to have $40,000 to put down on a house after 5 years. Your bank pays a 6% rate of interest. How much money will you have to set aside from a jackpot winning? See, you won 50,000. Okay, but you want to buy a house in 5 years' time. The price of a house in 5 years' time would be 40,000. Then you want to know that how much do you need to invest right now? Okay. Oh, yo. I don't know why it goes like this. I don't know how to delete it. No. Create another one. Okay. How much is the price of a house in 5 years' time? 40K. And we are right now here. I want to know that how much money I need to invest right now in order to be able to buy the house after 5 years at this price. Okay? Okay, means future value is 40,000. Number of years is 5 years. Interest rate is given to us at 6%. Okay, we have all the variables. We just plugging it into this formula that we already have learned, yeah? This formula, you remember this formula? We have the future value, we have the interest rate, we have the number of the years. For a single cash flow, then that is a number. It means that right now I need to invest 29,000 in my account. After 5 years, I will be having 40,000, which is enough in order to buy the house. Guys, any question up to here? Any question?
No.
Okay. And here explains that if you want to do this question with the calculator, how to do it. If you want to do it with the spreadsheet, with the Excel, how to do it. Or if you want to refer to the table, how to do it. Okay, another most important things for you always is draw timeline. See, what I draw is called timeline. You make sure that you always, whenever you want to do any finance question, you always draw the timeline. Year 1, okay, year 0, year 1, year 2, year 3, year 4, year 5, it depends on the question. And if you have any values, you write all the values, okay? This is called, what is it called? What is it called? Timelines. Yeah. And you make sure that always, whenever you want to do any finance question, you draw it, yeah? If you're taking any value from the present time to the future time, is called compounding. If you're bringing the future value to the present value or present time, it is called discounting, okay? Okay, we already have seen this part that this is the original formula that we have. We have 4 variables in this formula, but it depends. Sometimes 3 variables are given to us. We need to find another variable. For example, for this part C, Future value is given, interest rate is given, n is given. We are looking for the present value. For this part, future value is given, present value is given, n is given. We are looking for interest rate. And for this part, future value given, present value is given, interest rate is given. We are looking for the number of the years. And you need to learn how to work with this formula. Okay, here talks about the applications of the time value of money equation. Calculating the amount of saving required for retirement. So we all gonna get retired one day, isn't it? If I want to have $2 million in 10 years time, I need to know that how much do I need to invest right now. Another application is determining future value of an asset. For example, if I buy a property, I want to know that how much the value of my property gonna grow in 10 years time, 20 years time. Also, we can use that concept in order to calculate the cost of a loan. If I borrow $100,000 from bank and bank requires to pay 200,000 after 5 years, okay, I want to know that how much interest actually I'm paying. Then that is called the cost of a loan, that we can use this concept in order to calculate that. And we also can do the calculating growth rate of cash flows, as well as calculating the number of periods required to reach a financial goal. What does that mean? If I want to have 2 million in few years time, and I can invest every year 10,000 ringgit, then I want to know that after how many years I can have 2 million in my account. Okay, guys, it's almost 5. Do you have any class after this class? Hello?
Hello.
Do you have any class after this class?
No.
Okay. Right now, guys, is 5. If you want, you can leave the class. Is okay with me. What I would be doing is that I will record the class. Okay, I will record the class. I will continue this class. I will record it. And also I will record another chapter, chapter 4, and I will put it up in the blackboard for you. Okay, and later you can watch the video and you can refer to the video and the case studies and other materials. Okay, guys, when will be our next class? Guys, I'm asking you a question. When will be our next class?
Yeah.
When is our next class? Next
Thursday.
week. Next week, yeah?
Thursday.
Okay. 2:30 up to 4.
Yeah.
Okay, 2:30 up to 4 would be our class. Okay. Guys, do you have any question right now?
No.
Okay, if you do not have any question, then I will see you next week, okay?
Okay.
All the best. Thank you very much. Take care. Bye-bye.
See you.
See you. Bye-bye. Okay, I will be continuing the chapter 3. Saving for retirement. There is an example that we can see. Your retirement goal is $2 million. The bank is offering you a certificate of deposit that is good for 40 years at 6%. What initial deposit do you need to make today to reach your $2 million goal at the end of 40 years? See, we have the future value, but we want to know that how much do I need to invest right now? It means that I'm looking for the present value. And I have the interest rate, and I have the number of years. And it's quite easy. We just plug in it into that single cash flow formula. See? This is what we are looking for. We have the future value, we have the interest rate, a number of the years. It means that right now I need to invest this amount of money in my account and not to touch that money. After 40 years, I will be having $2 million in my account. Or if you want to do it via the Excel, this is the way you can do it via the Excel. Okay, there's another example for you. That we can just go through it and do it yourself. Okay. Another variation to that formula is what's the cost of that loan or interest rate. It means that out of 4 variables, we have 3 variables. We have future value, we have present value, we have the number of years, and we are looking for the interest rate. John, a college student, needs to borrow $5,000 today for his tuition bill. He agrees to pay back the loan in a lump sum payment 5 years from now, after he is out of college. The bank states that the payment will need to be $7,012.76. If John borrows the $5,000 from the bank, what interest is he paying on the loan? See, this is the amount he's gonna borrow. This is the amount he needs to pay after 5 years and after 5 years. And we need to know that how much interest actually the bank is charging him. Okay. We have all the ingredients. We just plugging it into the formula, and we're gonna get the number which shows that actually the bank is charging him 7% interest rate. And this is the way of doing it via the Excel. And that's an example you can refer to. And this question, okay, is giving you the present value, giving you the future value, as giving you the interest rate. The only thing that you're looking for is the number of the years, which you have seen an example like this previously. Okay, there is a rule, they call it doubling of the money, which is a shortcut actually. They call it the rule of 72. For example, if you have 100 ringgit, if you want to make it double, means make it 200 ringgit, then with a particular interest rate, then you can calculate how long does it take time. The rule of 72 estimates the number of years required to double a sum of money at a given rate of interest. For example, if the rate of interest is 9%, it would take 72 divided by the interest rate 9, which is equal to 8. It means that it takes 8 years to double your money. Okay, from here onwards, there are additional problems for your exercise. You can go through and do the questions. And if you have any question, any doubt, if you're not clear, you can ask it from me.